Hello. In this video we're going to be using rectangles to estimate the area under this parabola. So the parabola is y equals x squared. We're going from where x equals 0 to x equals 1. And when I say that, we're talking specifically about the space underneath the curve up until the x-axis, so between the curve and the x-axis. Now, what I have here is technically a square. That's 1 unit in length, and that's 1 unit in length. And so if I draw this in, the area I have there is 1. And obviously that's too big because we're looking at this. This is the part that we're trying to figure out the area for. And if I were to even, let's say, draw the diagonal in, this area is now, the area of the square was 1 by 1 or 1, and I've cut it in half, so I would have a guess of 1/2 square units as the area for this. But that obviously is too big because we don't want to talk about this part that I've shaded in blue. We only want the part underneath. So obviously my first estimation of 1/2 is too big. So let me get out the eraser. And let's look at this in a different way. And so the directions said that we should try using rectangles. And so what I'll do is I'll first create 2 different rectangles. So at 1/2, here we go, that's a better color. So at 1/2, I'll create this rectangle, and then at 1, I'll create this rectangle. And so we can just find the length and the width of these 2 rectangles. And I know both of them have a width of 1/2. The big one has a height of 1, right, because we went over to 1 and then 1 squared. And then this one at 1/2, well, that would be our 0.5 squared, or 0.25. So the area there is 1/2 times 0.25 is 1/4 plus 1/2 times 1. Well, 1/2 of a 4th is 1/8 plus another 1/2, and that gets us a guess of 5/8, which we know is definitely too big. So let's try to do even better. So I'm going to erase these, and instead of doing 2 rectangles, let's try 3. Or you know what, we'll try 4. So I'll use blue this time. We need more to erase here. There we go. Get out of there. We don't need you. Alright, so let's go every quarter. So there's a quarter. So that's a length of 1/4. Right there at a quarter, there's a length of 1/4. There's another quarter, the length of 1/4. There's a quarter. And so again, this height is 1. This is 0.75 right here. That's a height of 0.75 squared, or 3/4 squared. 3/4 squared being 9/16. This is right here 1/2 squared, or 1/4. This is 1/4 squared, or 1/16. So the area here, and I'll need a lot of space for this, my first rectangle is 1/4 times 1/16, plus my next rectangle is 1/4 times 1/4. My next rectangle is 1/4 times 9/16. My final rectangle is 1/4 times 1. 1/4 times a 16th is 1/64, plus 1/4 and a 4th make 1/16. 1/4 and 9/16 makes 9/64, plus 1/4 times 1 is simply 1/4. And if I get a common denominator for all these, so 1/64 plus 4/64 plus 9/64 plus 16/64 equals 1 plus 4 is 5, plus 9 is 14, plus 16 is 30 out of 64, or rather, that is 15/32, which is a little less than 1/2. So that makes more sense than our previous 2 guesses so far. And what I'm going to do is, at this point, I'll just go for a third try here. So instead of doing fourths, this time I'll do eighths instead. And let's see, I haven't used red yet, so at 1/8, there's my first rectangle. It's a very small one. Here's another 1/8. Here's another 1/8. Here's another 1/8. Here's 1/8. And so on. You can see how this is going to hopefully take up less space over top of the curve than what we've done in the past. So each of these are 1/8 in length, or width perhaps we should say. And so I'll go over here with my red this time. So my leftmost rectangle is 1/8 by 1/8 squared, plus the next one is 1/8 by 2/8 squared, then 1/8 by 3/8 squared, and so on until I've added on 1/8 times 8/8 squared. Instead of evaluating all of this, let's look at this as, if I factor out a 1/8 that's in common with everything, it's 1/8 squared plus 2/8 squared plus 3/8 squared, and so on until 8/8 squared at the very end. Or rather, I can look at this as 1/8 times 1 squared over 64 plus 2 squared over 64, and so on until we have 8 squared over 64. Or rather, again, 1/8, and then I'll use my sigma notation from I equals 1 up until 8 of I squared over 64. And so this results in 1/8 times 1/64 times our sum from I equals 1 to 8 of I squared. And we know that that is really just going to be 1/8 times 1/64 times, and then we can input our formula for I squared, which would be 8 times 8 plus 1 times 2 times 8 plus 1 all over 6. And then we evaluate. 1/8 times 8 would cancel, and so we have 9 times 16 in the numerator, 64 times 6 in the denominator. We can make life easier on ourselves even still. The 64 and the 16 cancel, leaving me a 4 on the bottom. I'll take a 3 out from top and bottom here, and we end up with 3 in the numerator and 8 on the bottom. And we have 3/8 now as my guess, which is still even closer. Well, it's even less than the 1/2 that we had before. Okay, and so what we'll end up doing is continuing to pick smaller and smaller and smaller rectangles until we get closer to the exact area underneath this curve. We'll save that for a later date. For now, we are done.